important points that we have studied yesterday. So like electron withdrawing groups are present. So what they do? They increases the electron withdrawing groups, increases the acidic strength or decreases the basic strength. It means for an organic acids, for example HA is an organic acid. To this acid, if any electron withdrawing group is there, that will be more acidic when I compare with the simple organic acid. When I compare it with the organic acid which contains electron releasing group. So this is what the acidic nature order. So which is more acidic here? Electron withdrawing group containing organic acid is more acidic. Okay. So now you have studied about electron withdrawing groups in mesomeric effect like -I groups and also in inductive effect. Okay. Now tell me the order, do you have written that order? Like nitro group first, the next cyanide group, next like that fluorine, like that you have written. Once check that and I will be giving you one question here. See, this is a carboxylic acid. Now here it is having hydrogen atom, otherwise it is a CH3. Okay. Now to the same carboxylic acid here, what I am adding here CH2, in the place of one hydrogen I am writing one nitro group. Now CH2, this is also electron withdrawing group -I group only, but which is stronger? Nitro group. So that will increases its acidic nature more. So B will be more, after B C, between AD. See here only one alkyl group is there, here two alkyl groups are like bigger alkyl group. So we know alkyl groups are releasing groups, but bigger alkyl group means more releasing now. So more -I, more +I. Both of them are releasing groups, both of them are +I groups only, but which is more +I? This ethyl. Okay, that's why it is least acidic. So you just remember electron releasing groups decreases acidic strength, and whereas electron withdrawing groups increases the acidic strength. So based on this B, C, A, D. So this is how you need to answer. So yesterday also we have covered some examples related to these. This one from yesterday's class. 3 to 1. Okay. So these are the groups. See, are you able to see from there, from back bench? See, if yesterday I have given something like this, benzene ring with the OH group. Instead of saying like this, I am generalizing them, like benzene ring is there, some group G is there. See, on OH group what we have? Lone pair electrons are there. See, lone pair electrons are there means they can be donated into the ring, no? So what type of effect it is? See, pi bonds are like this, and I am writing a generalized group G. See, this G group is having some lone pair electrons on it, non-bonding electrons. See, lone pair, sigma bond, pi bond. It means they are in alternate position now. If they are alternate position, conjugation takes place. So now conjugation is taking place, and during the conjugation this group G only giving its electrons now. So I can say this group as electron releasing group or +M group. So whenever there is a +M group on the conjugative system, that increases or that activate that group, I mean that activate this ring. See, it is giving the electrons now. So what happens in the ring? Now negative charge is created. So electron density in the ring, what happens? Increasing or decreasing? Increasing. So all these groups, if you observe, what is common you are seeing there? All of them have lone pair electrons. So all of them are now considered as electron +M groups are electron releasing groups. Now where the negative charges are created on the benzene ring, if that electron releasing groups, ortho and para. Therefore if I add any electrophile, that goes to which positions? Electrophile I am adding. Electrophile means electron density rich or poor. That electron deficient species goes to the more electron density. See, electrophile means it is electron deficient of positive charge. That positive charge goes to which positions? Either ortho or para, because negative charge is at ortho and para. So that will be your major products. That's it. Fine. Next one, if you observe these groups, all these groups if you observe, tell me which group I wanted to mention here on the benzene ring. You just cyanide. Okay. CN. So CN means C triple bond N. So carbon has 4 bonds. Check once. So do we have any non-bonding electrons on the carbon? No. And again to this carbon, the attached atom is there, na, that is more electronegative than the carbon. Check once. In all these things, common thing is, see here, if nitrogen is there, that nitrogen contains no lone pairs, adjacent oxygen is more electronegative. Here also same story. Here also carbon contains oxygen, oxygen is more electronegative, and a carbon does not have any non-bonding electrons. Like that, if you observe, you can generalize that there is no presence of electrons, lone pair electrons on this atom which is directly attached to the ring. Therefore, it cannot release electrons like this as we studied here. Okay? Therefore, what happens? It will not be releasing any electrons into the system, but it is dragging the electrons towards themselves by electronegative atom like this. See, pi bond will be polarized towards which side? Nitrogen side. Now, what is the charge you are creating over here? If it is placed, what it will do? So, it will drag the pi electrons from the ring. Now, what happens in the ring? Positive charge you are creating or negative charge you are creating? It means what you are doing, you are activating the ring or you are deactivating the ring? See, activating means you should supply the electrons into the ring. What you need to do? You should supply electrons into the ring. But here what is happening? It is only dragging the electrons from the ring now. So what is the charge you are creating here? So I can say all these groups are what? Electron withdrawing groups, and they deactivate the ring. So now where the positive charge you are seeing now? Ortho. Again, if this is shifting here, where this positive charge again shifts here, tell me? See, this is shifting from here to here, between this carbon and this carbon. Like this I can write. Here already we have. So here at the fourth position again positive charge. Yes or no? Yes. So now you are seeing positive charges either at ortho and para positions. Even negative charges also ortho and para. So do we have any effect at the meta position? No. So mesomeric effect will be observed only at ortho and para position. Now to these electron withdrawing groups, I am containing benzene ring, I am adding a electrophile. Where it will go, tell me? Meta. Why? Because see, ortho position already electron deficient, para position also electron deficient. See, that positive charge, this positive charge repel each other. So actually if I want to say that electrophile won't attack here, won't show reactivity actually. But if I want to do a forced reaction, you must react with this, means what it will do now? It will goes to meta position, because relatively more electron density is present at which position? Electron withdrawing group ఉన్నప్పుడు పాజిటివ్ ఛార్జ్ ఆర్తో పారాలో ఉందమ్మా, అంటే ఏ ఛార్జ్ లేకపోవడం బెటర్, హ్యావింగ్ ఏ పాజిటివ్ ఛార్జ్ కదా. సో ఎలక్ట్రోఫైల్ గోస్ టు విచ్ పొజిషన్ నో? Like that you should understand the reactions, that's it. Okay, right. After this the questions will be like this. During the reaction that intermediate species are formed now, let us say there is a carbocation formed like this. Okay, now they will ask you which carbocation is more stable. OH. Which carbocation is more stable? First. See, carbocations means electron deficient or electron rich? So if they are deficient, what type of groups will stabilizes them? So now phenyl ring properly, it is also proper, extra here we have OH group, here NO2. So what is the nature of this OH group? Releasing or withdrawing? See, this is having lone pair electrons, so it will activate the ring by donating the electrons. This fellow also required what? Electrons. So he is helping by giving the electrons. So now what happens to the stability of this carbocation? So electron releasing groups, particularly plus same groups, increases stability of carbocations. Are you getting what I am writing? Okay. Whereas electron withdrawing group, see, this fellow is electron withdrawing group, he will only withdraw the electrons from the ring. Already here it is electron deficient, it is again dragging the electron. What happens to electron density here? Further decreases. So stability decreases. So which is least stable? C. Now what I can make? Electron releasing groups increases stability of carbocation, whereas withdrawing groups decreases the stability of carbocation. Is this clear? Now tell me the order. B, A, C. Everyone clear with this? Okay. One more example. Tell me, between A and B, which is more stable? Tell me. Between A and B, which is more stable? See, conjugation means how they should be? Alternate. See, pi bond, sigma bond, vacant orbital. So now this will be shifting from here to here. This is what the conjugation means. But here they are not alternate, they are adjacent. So there is no conjugation here. But here we have a conjugation. Whenever, see, it is very simple, ma. Whenever there is some charge, that charge must be spread around the atoms. మీ చేతిలో ఒక బరువు ఉండి మీరు ఒక్కరే పట్టుకుంటే మీకు ఇబ్బంది ఉంటుందా ఉండదా? If everyone shares, you feel relaxed. So now this charge is shared between these three atoms. But here, there is no conjugation. If no conjugation, that positive charge present only on this carbon. So it means this is less stable, this is more stable. Okay? So out of this carbocation is more stable. Now listen here clearly. I am saying few names now. You need to understand or you need to remember them. What is this called? Benzene ring. So this is C6H6. Okay. It means on each of this carbon there is one hydrogen like this. Yes or no? Each carbon with one hydrogen. Okay. Now what I am doing? I am removing one hydrogen. What happens here? Some connection is there like this. So I can write C6H5 like this, some connection. What is that? Benzylic position or benzylic carbon. What is that carbon called? If this kind of ring is there with positive charge, you should say phenyl carbocation. And what about this? Benzyl carbon I am saying. So if there is chlorine, you should say benzyl chloride. Now what I am doing is I am writing a positive charge on it. Benzylic or simply benzyl carbocation I should say. What I am saying? Benzylic carbon or particularly benzyl carbocation. Is this clear? Okay. Now they will give you four names. So phenyl carbocation and benzyl carbocation I am writing here. So tell me, between phenyl carbocation and benzyl carbocation, which is more stable, they will ask. See, for understanding purpose, you write these ring electrons like this, and here also like this. So which is more stable out of these two? A or B? B. Why B is more stable? There is no conjugation here, so this is no conjugation, highly unstable. Okay? And this is, see, this carbocation can be stabilized by like this. Yes or no? Conjugative position or not? Alternate position or not? So it is stable carbocation. Okay? Do you got the difference here? Yeah. So now, simple ma. See, before explaining further reactions itself, ఇంకా మనం ఏం చదువుకోలేదు. హాలో ఆల్కేన్స్ చాప్టర్ మొదలు పెట్టలేదు. ఈ కాన్సెప్ట్ ఒకటి మీకు అర్థమైందా? ఇప్పుడు మీరు ఒక ఆన్సర్ చేస్తారు చూడండి. This is benzene ring, CH2, Cl is there, and here direct Cl is there. You need to replace with aqueous NaOH. With what you are treating? With aqueous NaOH. See, Na plus OH minus. See, what is the reactive site here we have? General ga meeku mee common sense em cheptundo adi cheppandi answer. Okay. So, ikkada oka chlorine undi. Here we have a chlorine. So one of these chlorine should be substituted by this OH group. Which will be substituted, I am asking? Up one or down one? Why up one, why not down one? If I remove these, you are going to get a phenyl carbocation, which is highly unstable. But if I remove this as a chloride ion, you are going to get a benzyl carbocation. Benzyl carbocation can be stabilized. Therefore, which will be replaced? Only this upper one. Therefore, what is the product formed here? The remaining chlorine here remains as it is, no disturbance there. So it becomes CH2OH. That's it. Ardhamainda? So if you practice this mesomeric effect, inductive effect, hyperconjugation properly, without knowing the other chemical exactly name also you can do the reactions, like we using just common sense. See, OH minus is there, what are the two reactive sides? Yeah, if I remove this, we will get unstable, so don't remove this. If I remove here, we will get a stable carbocation, so remove this and replace that with OH, like this. Is this clear? Okay. Now what are the two names I told you? This type linkage is phenyl, phenyl halides, aryl halides. This one, benzyl halides. Okay, next one. Here, look at the system, CH2, double bond CH, CH2, Cl, CH2, double bond CH, Cl. Between these two A and B again, they will give like this. See, if I remove this chlorine, where do we get the positive charge? On this we will get the positive charge. Yes or no? Yeah. So now that carbocation generated is called allylic carbocation. What is it? Like this we will get now. Here you remove chlorine. Like this you will get. Yes or no? Is these two things are clear or not? After removing, we are getting a positive charge here that can be stabilized by conjugation. See, alternate position are there or not? Yes. So what is this called? Allylic carbocation. This is called vinylic. What is it? Vinylic or vinyl carbocation. Which is more stable out of this allylic or vinylic? Again allylic. Okay. Now simple reaction. Same. If I ask you, giving these two things, I just wanted to ask you to treat this with aqueous NaOH. Which will undergo substitution? First one or second one? Only allylic. So this chlorine comes out, OH enters in, will get the final product. But here no that kind of reaction. So now here you got one statement. Vinyl halides, aryl halides will not undergo substitution reactions. Do you got what I am saying? Vinyl halides, aryl halides does not undergoing substitution reaction, whereas benzyl halides, allyl halides will easily undergo substitution reactions. Substitution means what? One group is removed and replaced by another group. So substitution reactions taking place by which one? Allylic and benzylic. Sir, out of this benzylic and allylic, which is more easily undergo? Benzylic. Why benzylic? Because more conjugations now in benzylic, so more easily it will undergo. Is this clear, everyone? Okay. Next one. Up to here it is done. Next one, same story with this. Okay. See, on the applications of mesomeric effect and inductive effect, we can continue our discussion for like 1 week also, even for 10 days, 15 days also. GOC is that much important if we want to do. But we have very less time. Anyways, I will try to cover maximum important things. Okay, you just tell me. ABC. Which is more stable? Which carbocation is more stable, I am asking. First of all, tell me, are there allylic systems or not? Yes. See, alternate pi bond, vacant orbital, so conjugation takes place. Along with that extra part, here what type of group we have? Releasing group or withdrawing group? See, it will releases electrons like this. It means this conjugation is enhanced. It means this is more stabilized. So which carbocation is more stabilized? B. What about this group? See, it will withdraw. See, because there is no lone pair electrons on nitrogen atom, so the pi bond will be shifting towards oxygen, and this pi bond shifting towards nitrogen here and creating a positive charge. See, positive charge, like charges adjacent to each other means highly unstable. So it means which is the least stable? C. And in between A. That's it. Do you got the concept here? Okay. The same thing, the concept you have used, now apply for carbon anions. For what I am saying? Carbon anions. Okay. So carbon anions examples you take. fast. What type of group here? No, just benzylic carbon anion is there. Here benzyl carbon anion with nitro group. What is the nature of nitro group? Electron withdrawing group. What about this NH2 group? Electron releasing groups. Now carbon anion means already they have more electron density. So that should be withdrawn towards themselves. So where do we have withdrawing group? So that will be more stable. So B, A, perfect. Everyone got these concepts? Yeah. Next. Answer me this. What they are asking, once read the question. See, what they are asking about? Like they are asking about acidic strength, right? So organic acid strength increased by what type of groups? Withdrawing groups. So where do we have withdrawing group here? Here this is the electron withdrawing group. Next one, what about this? See, actually it has lone pair electrons now, sir, you might be having, so that it can be also an electron releasing group. But whenever halogens are there, due to more electronegativity, only in case of halogens. Okay, so inductive effect is more dominating than mesomeric effect. In all other cases, mesomeric effect is more dominating than inductive. So now tell me, out of this, first of all, as per the overall order, which group is strong electron withdrawing group? Nitro group. So it is stronger electron withdrawing group, so more acidic this will be. So I can write it 2 first. After that 5. After this, see here we have methoxy group. What type of group it is? Methoxy. So methoxy group, like lone pair electrons are there now, so it can act as plus M group, and oxygen more electronegative, minus I group. So here what about this group means? It can act as inductive effect, plus I group. Is there any lone pair electrons on it? No, no mesomeric effect here. But one more we are going to study now, hyperconjugation will be there, but here it won't act. Okay, anyways it will be electron releasing group. Okay, but which is stronger electron releasing group? See, mesomeric effect is there now, that's why it is more stronger releasing group. But which type of groups we required? Withdrawing. Both of them are releasing groups, and here there is no such group. It means no such group is better than having releasing groups. So what I should write? 1. After this 3. Perfect, perfect. 4. Okay. Got everyone? Yeah. Next. Same question, they will ask you Ka order. Same. They can also ask pKa order. Okay, perfect. Okay, next one, if you observe this, order of acidic strength. The first one here you are seeing is sulfonic acid. What is this? Sulfonic acid means like this you can make OH. Like this we have. Okay, so sulfonic acid is inorganic acid. It is what it is? Always remember, inorganic acids are more acidic than organic acid. What I am saying? Inorganic acids are more acidic than organic acid. Organic acids, inorganic acid means what? See, carboxylic acid means carbon is present now, but here what do we have? So that's why I am saying it is inorganic acid. Here it is. So what I am saying? Inorganic acids are more acidic than organic acid all the time. Similarly, inorganic bases are more basic than so simply remember, organic acids, organic bases, organic acids and organic bases are weak. What they are? Weak. Like weak acids, weak bases, most generally. Remember that. Okay. That's why what we have first? Sulfonic acid. Next, out of organic acids, carboxylic acid is more acidic. Okay, after that phenols. What they are after that? After that methanol. Alcohols, when I am saying alcohols, aromatic alcohol, that is phenol is more acidic. After that remaining aliphatic alcohols will be there now, like methanol, ethanol, propanol, butanol, all these things are there now, except methanol. What I am saying? Except methanol. All other alcohols are less acidic than water. Once again, except methanol, all other alcohols are less acidic than water. So that's why it is generalized like ROH. ROH means what? Alcohols. So this is also alcohol now, is particularly what I told you. Methanol is more acidic than water. Remaining all alcohols are less than water. That's it. Next one. Here it is alkyne it is. What is this? Alkyne. Triple bond is there now, alkyne. So alkynes are more acidic than ammonia and methane. Okay, perfect. Next. Okay, let's move forward. Okay, so I am saying about amines. Yesterday also I discussed about basic nature of amines. I told you basic nature of amines means what? They should have tendency to accept a proton. Amines, like basic nature means what? Tendency to accept a proton or tendency to release a OH minus ion. What I am saying? They should have more ability, like NaOH is more basic. Why more basic? Because it releases OH minus. Otherwise, I can also say tendency to accept a proton. If more tendency to accept a proton, more basic it is. Now, out of all this, which is more basic, I am asking. Remember, there is something called aliphatic, aromatic. What I am saying? Aliphatic, aromatic. Aromatic means most generally you might be having like benzene ring like this. Okay, now aliphatic means some chains will be there, no conjugation, you just remember. See, no conjugation means CH3, CH2, NH2 I am writing. Okay, and the next one, listen here what I am saying, clearly you just follow me. See, what is meant by basic nature once again? Tendency to accept a proton. See, the tendency to accept a proton means if these lone pair electrons are free, using that lone pair electrons only, they will accept the proton right now. If that electrons are free, easily accept the proton. So I can say that compound is more basic. Okay. See here, in these two compounds, lone pairs, sigma bond, pi bond, how they are oriented? Alternate. It means conjugation is there like this. Yes or no? Due to that conjugation, these lone pairs are less available to accept the proton. Yes or no? Next one. Here also lone pairs are there. They are also in conjugation. Amma ee electrons free gunnai ankondi, proton easy ga accept chestay. But avem chestunnai ikkada? Conjugation lo unnai. Are they available effectively? No. But here if I say these lone pairs are not in conjugation, so they can easily donate it to this proton and they can accept the proton easily. So always remember, aliphatic amines are more basic than aromatic amines. What I am saying? Aliphatic amines are more basic than aromatic. Again, so this is also aliphatic amine. Now I will tell you what do we mean by aromatic. Just listen. So what about these? Here, how many conjugations this nitrogen is participating now? One time. But this one conjugate with these pi electrons, again with this, again with this. So more number of conjugation now. Ante a electrons stronger they are taking into the ring. So they are very less available to accept the proton. Who is more available now? Second one. First one. After that, B. C. Is this clear? Okay. Now, ide ring ki, for this particular ring, I am inserting one electron withdrawing group. What it will do now? Further drags the electrons downside. Now, further less available to accept the proton. So I can say it is very least. Is this clear everyone? Okay. So now I am saying here one example. NH2 group with CH3, NH2 group with some NO2. Out of these two, which is more basic? First one or second one? Why? Because this strong withdrawing group decreases the basic nature. That's why you made two statements yesterday. Withdrawing groups containing amines are less basic nature I am talking. If electron withdrawing groups are present on basic like amines, their basic nature decreases. See, it is something like opposite to acidic nature. Okay, fine. Everyone clear with this? Yeah. Between these two you tell me? Yeah, it is already given. Aliphatic amine is more. Between these two you tell me? OCH3 means what type of group it is? What we have here, lone pair electrons releases now. So this lone pairs easily now accept the electron releasing group unte em chestadi, that will activate the ring. See, ive electrons istunaya. Please follow here. See, what type of group it is? What it will do, it will withdraw electrons. So these are very less available to accept a. So I can say this is least basic. There is no such group here. What about this group? If there is a releasing group, it will only releasing the electrons now. Ante not taking these electrons, but giving its electrons. Now these are little bit more available now. So it means which is more basic? A. Next one, B. Like this. Okay, done. Keep it aside. Next, hyperconjugation. What is the next concept? Hyperconjugation. So hyperconjugation means, see, carbon, how many valency orbitals are there? 4. It is making 3 bonds, let us consider. Like this 3 bonds are made. Now one more vacant orbital will be there now like this. Okay, let us say carbocation it is. What is this? It is a carbocation. Now to this carbocation, see, carbocation means electron deficient or rich? Deficient. Now what type of groups required for stabilization? See, now to this carbocation adjacent carbon is there now. That is called alpha carbon. What is that? This is called now alpha. This will be beta. Okay. Now on this alpha carbon, if any alpha like any hydrogens are present, those are called as alpha hydrogens. Okay. So to this empty orbital, this alpha hydrogen CH bond is there now, that sigma bond electrons are donated. Now if it is donating, just imagine what is happening here. Tell me. CH3, C, here downside H and H. See, here previously it is vacant. Now this bond, sigma bond electrons are shifting now. What happens? This single bond become now a new pi bond. Like this. And hydrogen remains here as H plus. Like this it is happening or not? Ardham avutunda, just taluptunnara. See, there is a vacant orbital here. Daniki em kavali? Electrons. That electrons are given from this alpha CH sigma bond. Only which bond? Alpha CH sigma bond. So it means the delocalization of alpha sigma CH electrons into vacant orbital, into vacant p orbital is called what? Hyperconjugation. So what is happening here? CH sigma bond is given. Like this it will be stabilized. Like that, how many times we have possibility for stabilization of this carbocation? With this alpha hydrogen, same story with this alpha hydrogens. It means more the number of alpha hydrogens, more is the stability of that particular carbocation. Is this clear everyone? Okay. Now look at this. This hyperconjugation is also called as no bond resonance. What is this? Why we are calling no bond? See, this bond is nowhere here. There is no bond here. So what I am saying? No bond resonance. Okay, also called as Baker-Nathan effect. What is it? Just remember that names. Hyperconjugation, no bond resonance, Baker-Nathan effect. Okay, now look at this. ఏమైంది ఎందుకు అట్లా అవుతున్నారు? Look at these 3 examples. Fast. Which is more stable? Why more stable? In the previous classes, sir, tertiary carbocation is more stable. Like that you have shouted. Why it is? Because how many alpha hydrogens are there? 3. So this side 3. So total 9 alpha hydrogens. 9 hyperconjugations are possible. More the number of hyperconjugation, more is the stability. Again, one methyl group can be considered as 1 plus I group. What is that? 1 plus I group. Like that, how many plus I groups are there? 3. So 9 9 hyperconjugations plus 3 plus I effects. Like that, for this one you tell me. 6 alpha hydrogens. Next, 2 plus I. Next, 3 alpha hydrogens. 1 plus I. So where do we have more number of releasing effect now, like hyperconjugation? C. And also more plus I groups also, the carbocation is more stabilized, like this. Okay, now what is the reason for stability of tertiary carbocation? Alpha hydrogens, like hyperconjugation as well as inductive effect. Okay, now one more thing, free radical stability also follows the same order I am saying. So why it is same order? See, I am writing like a dot here. See, these 3 bonds means can make 3 like this. See, already 1 electron is there. How many electrons are required to make a bond? 1. So out of these 2, 1 electron here it is there now. I mean from this bond, this electron get paired. So like that, CH, H, CH2, this here 1 radical. Like that, how many times it can be stabilized? 3 times. We got 3 alpha hydrogens. So more the number of alpha hydrogen, more is the stability of free radical. Okay. Now hyperconjugation explains stability of carbocations, stability of free radicals, but not the stability of carbon anions. Why not carbon anions? See, it is giving the electrons now. Already that has electrons. There is no meaning of again giving the sigma bond electrons in hyperconjugation for carbon anions. So that's why hyperconjugation won't explain the stability of carbon anions. It only discuss about carbocations and free radical. Now, and also it explains the stability of alkenes. What is that? Alkenes means this is one alkene. Next, what I am doing, just check. Like this I am writing. Which alkene is more stable I am asking. Again same story. Previously what I told you, carbocation I have shown you, then adjacent one is alpha carbon. Here also to this carbon, is there any adjacent carbons again? If adjacent carbon is there, that should be called as alpha carbon. Hydrogens on it called alpha hydrogen. Can I say this as alpha hydrogens? These are not in alpha hydrogens. See, do we have any alpha hydrogens here in this? How many alpha hydrogens? 3. To this double bond system, here adjacent carbon we have, this is alpha carbon, hydrogens are alpha hydrogen. Like that, here how many are there? 6 alpha hydrogens are there. Now look at here. Look at this example. Rewriting the same thing. See here, which bond it is? Pi bond. See, in molecular orbital theory you studied, if there is bonding molecular, then respect to anti-bonding molecular also there, like sigma, sigma star, pi, pi star. So here we have pi bond. Respect to pi star orbital will also be there here. Yes or no? Bonding molecular orbital lo electrons వేస్తే bond form అవుతుంది, anti bonding లో వేస్తే kada. So now same story. So this is pi bond, this is pi star. To this pi star, the sigma bonding orbital electrons are shifting like this. Now what happens, tell me? C, H, H, see what is happening? This bond is shifting here. It means there is a new bond formation between these two. This is the new bond, and this sigma bond shifts over here. Like this, how many times the conjugation is possible? Tell me. With this hydrogen, with this alpha hydrogen, like this. So more the number of alpha hydrogens, more is the hyperconjugation. More hyperconjugation, more is the stability. Okay? Like that, which alkene is more stabilized? Third one. So 3, 2, 1. This is stability of what? Amma, what ni pal. Done? Okay, now look at this. It will be there in your books. Just listen. Let's talk about carbocations. Which is most stable carbocation? See, no need of remembering also. Just understand the concept. C6H5 means what? Phenyl. Not phenol, it is phenyl. Like this, how many phenyls are there? Are there? Put the 3 phenyl rings like this. See, if there is at least one phenyl ring, what is the name I told you? What is this called? This system called benzyl. See, benzyl can be stabilized by these pi electrons. How it will be? See, like this conjugation is taking. See, are you observing? I am writing this kind of symbol all the time. So this is called resonating symbol. What is that? Resonating like symbol. Chemical reactions means you are writing like this. So this is for resonance. For what? Like this. Are you getting? If it is shifting here, this carbon is losing the bond. So that's why positive charge on it. Again shift once again this one. Like this. Where the positive charge should be written? Ekkada rayali positive charge? Ikkada. Okay, next conjugation like this. Okay, like these conjugations are taking place. See, one phenyl ring is there means like this 3 conjugation, 4 conjugations we have written. 5th one also possible. Okay, so like that 3 rings are there. So 3 times it will be like it is stabilized by all these 3 rings. Like this Carbocation can be stabilized here with the 3 phenyl rings. Next here 2 phenyl rings, that's why 3 is more stabilized than 2. Then next here tertiary carbocation is there. Next benzylic carbocation. Between tertiary and benzyl which is more stable? Tertiary. Okay. Next after that secondary carbocation we have. Next one allylic. Secondary most, the next allylic, the next primary, next phenyl, least is vinyl. So it is there in your book, no need of writing. Same order I have kept here. Same story with the, this one. What is this? Free radicals. First triphenyl carbon free radical, next diphenyl carbon free radical, next benzyl free radical. Here slight order is changed. You just check. So this will be the overall order. That's it. Next. The same story with respect to carbon anions also. Triphenyl carbon anion, next diphenyl carbon anion, benzylic carbon anion, allylic, methyl, primary, secondary, tertiary. That's it. Okay, fine. Okay, we'll start second chapter. Hydrocarbons. Okay, listen. The name says that what is this? Hydrocarbons. It means the compound contains carbon as well as hydrogen. Now, with this formula, we can have 3 types of compounds. They are called as what? Alkanes, alkenes, alkynes. So now what is the general formula of alkanes? CnH2n, alkene. What about this? Okay. Now what about the carbon-carbon? How many bonds are there here? CC single bond will be there. Okay. What about this? CC double bond. Here CC triple bond. Okay. Now each carbon here is what is the hybridization? Sp. Here it is sp2. Here it is sp. Okay. Next one. Here, if there is more percentage of S character, what I told you, more percentage of S character, more percentage of S character means it has more electronegativity. What I am saying? It has more electronegativity. So out of these 3 carbons, which carbon is more electronegative? You can say no? Sp carbon. It means alkane carbons are more electronegative than this, than this. Okay, remember this order. Okay, we'll discuss again about this. Next one. Okay, so due to this reason, see what I am writing. So tell me, what about this? This is an alkane now. Like how you will write? CH3 single bond CH3. This one C double bond CH2. This one C triple bond CH. So where do we have more electronegative atom? Last one. If this is more electronegative, what happens to this bond? See, carbon hydrogen is there. Which is more electronegative, I am saying? Carbon. Again with sp hybridization. Now what happens? This bond is shifted towards carbon side. Hydrogen comes out easily. It means hydrogen coming out as H plus ion outside means, can I say this is more acidic? Alkynes are more acidic than these things. So what is this order called? Acidic nature. Which is more acidic? Alkynes hydrogen. The directly attached hydrogen is there now to the alkyne carbon, that is more acidic. Write this. Okay. Now do we have any pi bond here in this? Alkanes are also called as paraffins. Paraffins. Paraffins means again these are less reactive. What is this? These are less reactive. See, all carbon like valence is satisfied by sigma bonds only in alkanes. right now. But in case of alkenes and alkynes, we have one pi bond. Pi bond is weaker bond. This is weaker. So due to this weaker bond, alkynes and alkenes show reactive nature. It means these are relatively more reactive than alkanes. Okay, and one more thing. Here, okay, that is done. Do we have any pi bond in this case? No. Here we have pi bonds, no? So you call this alkenes and alkynes as unsaturated compounds. What they are? Unsaturated compounds. What about this? Saturated. Okay, so this is some short understanding of all these three things. Okay, let's start our discussion with alkenes. With what? Alkenes. Okay. So first one is preparation of alkanes. Okay. So preparation of alkanes. See, all these are very important. Just try to follow me. First one is, what is the process? Hydrogenation of alkenes and alkanes. It means there is CC double bond like this. What I want? Respect to alkane I want. What I want? How many carbons are there here? With 2 carbons, what is the alkane we have? CH3, CH3. It means what I am adding from here to there, 2 hydrogens are increased. So I just need to add one H2. So addition of hydrogen to the compounds, to the substrate is called hydrogenation. What is that process called? Hydrogenation. So hydrogenation of alkenes and hydrogenation of alkynes gives you alkanes. What it will gives you? Alkanes. Hydrogenation of alkenes is also called as, this one is also called as Sabatier-Sandrance process. What is that? Sabatier-Sandrance process. So in this hydrogenation reaction, we need to use some catalyst. What we need to use? Catalyst. That is metal catalyst, like nickel, palladium, platinum catalyst is used. Particularly when I use this name, Sabatier-Sandrance reaction, it should be nickel. What it should be? Nickel. Okay, right. Again, when I use nickel as a catalyst, I need to use some high temperatures. For palladium, platinum, not required. Okay, what is the catalyst we are using in hydrogenation of alkenes and alkynes? Metal catalyst like nickel, palladium, platinum. Okay, and for which metal high temperatures are required? Nickel. If I use nickel, what is the name of that reaction? Sabatier-Sandrance reaction. Okay, fine. Next one. Next one, here the simple thing you need to understand is, look at this, what I am writing. Like this I am writing. This is pi bond now. A. This is also pi bond B. This is also pi bond C. Out of these ABCs, which bond is easily hydrogenated? Once again, which bond is easily converts from double bond to single bond? Means alkene to alkyne. Alkane. How can you say that? See, previously just now discussed about stability of alkenes. Which alkene is less stable? Out of these two, you tell me which alkene is less stable? A is less stable. Why A is less stable? No alpha hydrogen. Here we have 9, 3, 3, 6, 12 alpha hydrogens are there. 12 hyperconjugations are there. More hyperconjugation, more is the Stability. More stable, less reactive. What I am saying, more stable, less reactive. Out of these two, which will undergo hydrogenation easily? A. So reactivity, again, instead of saying hydrogenation, I can also say reactivity of alkenes. Which alkene is more stable? That will less reactive. Which is more stable here? B. So this is less reactive, this is more reactive. Okay. Now, which will undergo hydrogenation easily? A, then B. So same story applicable here also. Tell me. A, no alpha hydrogens. Do we have any alpha hydrogens? No. What about this C? Yeah, this side alpha hydrogens are there, this side also alpha hydrogens are there. Now what about B? So this B bond is there now. This is aromatic ring. Aromatic rings are highly stable. So don't disturb this. It means this is most stable, least reactive. So which is least reactive? B. Out of this AC, which is more stable between A and C? C is more stable, means it should be least reactive. It means first B, next C, highly reactive is A. Do you got what I am asking? Reactivity or hydrogenation. So I can simply give a relation. Reactivity is inversely proportional to stability. More stable alkene, less reactive. More stable alkene, less reactive. Next. Okay, the next reaction here is very, very important. You just see one of the favorite topic for your EAPCET examiner. If you open any paper, there will be one question on Wood's reaction. Okay, see, it's very simple, means very simple. See, alkyl halides. What I am saying? Alkyl halides with sodium metal. With which metal? Sodium metal in dry ether condition. What happens? Gives alkanes. Okay, what it will forms? Alkanes. See, this R represent alkyl group, halogen. What happening? This RR getting coupled, giving you the bigger product. For example, this is methyl chloride. Tell me. What is the product formed? RR na? So CH3? So higher alkanes are formed. From lower alkanes you are getting higher alkanes. See, it means lower number of carbons. One carbon only in the reactant side. How many carbons in the product side? 2. No. So smaller alkyl groups converts into bigger alkanes. Okay, one more thing. 1 plus 1? 2 plus 2? 3 plus 3? 6. See it me. Okay. So you just follow whether you add odd, what I am saying, whether you add odd numbers, even numbers. Final one is what? Even only. It means Wood's reaction is very good or very favorable for preparation of even number of carbons containing alkenes. Like see, how many carbons are there? After adding? 2. If I am giving you ethyl, tell me. How many carbons are there? 2. So you will get 4. Butane. So if it is odd, even. So it means this Wood's reaction is very suitable for preparation of compounds or preparation of alkanes having even number of carbons in the final product. Which one? Even number of carbons. So, sir, I want only odd number of carbons, means what is the scenario now? How can we do that? It means, for example, I have CH3, CH2, CH3. How many carbons are there? 3 carbons are there. So now what is the best alkyl halide I can prefer here? One alkyl halide with 1 carbon, another one with 2 carbons. Like it means methyl chloride plus ethyl chloride plus methyl chloride. Sodium in dry ether. So now see, remove these chlorines. What happens? 1, 2, 3. 1, 2, 3. We got this. But if I want to do this reaction, along with my propane product, we'll get other possible products also. What are other possible products? This fellow can combine with itself. If it is combining with itself, what is the product formed? two carbons are there, na? Again, two more. Butane. Like I can write butane. This fellow also can combine with itself. One carbon means add them, two. So CH3, CH3. See, when you are taking two different alkyl halides, how many types of products possible? Three types of products. Simple, you just adding them. Simple, meeku ada concept em teliyakapoyina kuda how many possible products are there means what you will do. It can combine with itself, so that will get like this. It can also combine with itself, will get this kind of product. Cross couple, this one is coupling with this one, will get product like this. So how many possible products? Three possible products. Okay, so it means when you use two different alkyl halides, how many possible products it is formed? Three, generally three. Okay, you need to look for the question properly in the exam. Okay, next one. Here, in order to prepare odd number of containing alkane, Wood's reaction is not a suitable one. Why not a suitable one? Because along with our main product, some other major byproducts are also formed like this. But if I want only even number of carbons, it is preferred. Is this clear, everyone? Okay. But finally, Wood's reaction means what should come into your mind? Like alkyl halides, upon treating with sodium in dry ether gives alkene. Okay. So if it is propyl bromide, what is the product formed? Propyl bromide. Propyl means how many carbons? 3. 3 plus 3. 6. Hexane will be the product, like that. Okay, next. Okay. See, before coming to this, you just tell me, I want butane. What I want, the product? Butane. If I want butane, what is my starting material in Wood's reaction? Ethyl halide, like ethyl bromide, chloride, like that. Okay. Now look at this question. They have mentioned like this. They given product sodium diether. What should come to your mind? What is my starting material? What to do? Now when I ask you butane, what is the starting material you told? So you just disconnected them into the half. Here also you try to disconnect into the half, two equal halves. Write in the book now. You need to give the IUPAC name for that. See where I should break. See this one same. CH also same. So CH2 same. So I am breaking into equal halves. So I just want to insert one chlorine over here. That's it now. Chlorine or bromine. Okay, bromo they are saying na. So bromine you put. Okay. So now. So CH2Br. This side CH. Here CH3, here CH3. That's it. What is the name of this compound? 1, 2, 3. So 1 bromo, 2 methyl propane. Which option is that? Clear, everyone? Yes. Next, go with the next one. This one. That's it. So you might get one doubt now, sir. Why do we prefer only dry ether? Like I will only use ether. What is the problem? Yeah, I don't have problem. If you use, you have problem. Okay. See, if you take alkyl halide, sodium, in dry ether only it is mentioned. Why not ether or any other wet conditions? If you throw this sodium in water, what happens? Have you tried in your labs anytime? Have you seen anywhere? If you put alkali metals in the water, it will give you fire. Like exothermic reaction takes place. That's why we should not prefer what? Dry, wet conditions. We should prefer only dry conditions. Okay. So if I use wet conditions, what happens? Exothermic, like fire will come out. Okay. And see this sodium reacting with water, what happens? It will forms NaOH and H2 gas is released. Okay, so we should not prefer what? Wet conditions, only prefer dry conditions. Next. Okay, let us, other ways we'll go with another way. Wait a minute. Okay, look at this. What is the first method I told you? Hydrogenation. Alkenes and alkynes adding H2 in presence of metal catalyst gives you the final alkene. This is the first one. Next one, what I told you? Woods reaction. So Woods reaction means what? Alkyl chlorides or alkyl halides with sodium metal, dry ether condition gives you alkene. This is also fine. Next method is, let us finish from this side. Same alkenes, what I am saying, alkenes in presence of hydrazine, like NH2 is called what? Hydrazine and H2O2. This also gives you respect to alkenes. Like how many carbons are there here? Respect to alkene means what is it? So same thing you can also do using palladium and charcoal. What is that? Palladium, charcoal. Next one. Here this reaction is important. Alkenes using B2H6, this is called hydroboration reaction. What is that reaction? Hydroboration of alkenes. What I am saying? Hydroboration of alkenes in acidic medium. In which medium? Gives you alkenes. In basic medium gives you alcohols. In which medium gives you alcohols? Basic medium. Okay, I will tell you about basic medium later. But here you remember, whenever you see B2H6 or BH3 with alkene, what is this compound, you tell me? Acid only, no? It means you are doing hydroboration in acidic medium. So what is the product formed? Alkene. For example, how many carbons are there here? 3 carbons. What is the respect to alkene? Propane, like CH3, CH2, CH2. Okay, like this you write first. Now I am adding B2H6 and I am adding this thing. From here you will get one H plus. I am indicating this H plus coming from acid is red color H plus. Hydrogen that comes from this borane means I am indicating with yellow color. So that yellow color hydrogen comes here, that red color hydrogen comes here. Formed product is alkene, but a hydrogen ekkadi nundi ochindani adugutunna. Acidic hydrogen comes to this terminal side. Which side? Terminal side. That borane hydrogen comes to this internal side. Remember. Okay, I will tell you other simple way trick when I am giving explanation for basic condition. Okay, next one, what is the compound you are seeing here? So lithium aluminum hydride, sodium borohydride. See how the name is ending? Hydride. It means ide means negative charge. Hydrogen with negative charge, hydride. See, this is H minus. If this Br is coming out as Br minus, what is the charge you are creating? So you just add this negative on it. What you will get? RH. If it is methyl bromide, product is methane. If it is ethyl bromide, propyl bromide. Okay. Next, same story with sodium borohydride or lithium aluminum hydride. Okay. Next one. See, same alkyl halides with ZnCu. ZnCu in presence of alcohols gives you respect to alkene. Like ethyl bromide is there, na? Ethane will be the product. Next one. Woods reaction, you tell me once again. Alkyl halide. Same. Alkyl halides. What I am saying? Alkyl halides with zinc. Zinc, what is the charge on zinc we have? +2. See, a metal, carbon is non-metal now. So when they are reacting, carbon should get negative charge, zinc will get positive. How much positive? Plus 2. So each carbon minus 1 means this should be 2. So I can say dialkyl zinc like R2Zn and CH3Cl. What is the charge here on this carbon now, tell me? Cl means plus 1. This chlorine has minus 1. So this R minus will attack on this plus carbon, will get RCH3 as a new compound like RCH3. It means, I will tell you one example here. What is the product formula, tell me? What happens here? Firstly, chloride ion comes out. What is the charge you are creating? What about this thing? Zinc plus 2. It means each carbon here will be minus. So this minus comes and attacks with here. Chlorine goes out. So what is the product form? CH3, CH2, CH3. Are you getting what I am doing? Yeah. So you can simply say alkyl halides with dialkyl zinc gives you respective higher alkane, like this R group, like a coupling product you will get. Okay, next one. What is the name of this reaction? Franklin reaction. What is it? Franklin reaction. Next one is here R group means what? Alkyl. How many alkyls are there? 2. So dialkyl lithium cuprate. What is this? Dialkyl lithium cuprate is called Gilman's reagent. What is that? Gilman's reagent. So same story, whatever you have understood here, instead of using this dialkyl zinc, here I am using like that Gilman's reagent R2CuLi. So what is the product formula, tell me? Metals means positive charges, alkyl group means negative charge. So this negative charge will add it to that and you will get CH3, CH2. To that what I should add? Whatever the R group we have here. Okay. So sir, when to use this reaction means, ippadaaka meeru Woods reaction chadivinappudu we have discussed we cannot use that for preparation of odd number of carbons containing alkane. There we can prefer this method, Gilman's reagent, and name of this reaction is called Corey-House synthesis. What is that? Corey-House synthesis. Corey-House synthesis. So what is the use of Corey-House synthesis? Alkyl halides with Gilman's reagent gives alkanes. Once again, alkyl halides with Gilman's reagent gives alkane. This is the best method, one of the best method for preparation of unsymmetrical alkanes. What I am saying? Unsymmetrical alkanes. For example, you got an order to prepare pentane. What you need to prepare? And in your company you have only ethyl bromide. What you have? So now what should be the Gilman's reagent you should use for preparation of that compound? Cuprate. Okay, fine. Just listen here. From this slide you can expect one question. What do we have here? Check once. What is this functional group called? Like CORR. Ketone or aldehyde? Ketone. Ketones with zinc amalgam, like Zn is there, Zn with Hg. This is called what? Zinc amalgam. In acidic medium. In which medium? Acidic medium. So ketones or aldehydes with zinc amalgam gives you alkenes. What they will give you? Alkane. Very simple, you just need to identify and I will give the product, how to identify, how to give the final product. See, here this C double bond O is there, no? This C double bond O. Just remove oxygen, put 2 hydrogens on that carbon, like this. What is alkane now? CH3, CH2, R. This is your final product. It means You just see here what I am writing. Zn, Hg, HCl. Tell me, what is the product formed? Just remove this C double bond O. There I need to put 2 hydrogen to satisfy the valency. Hydrogen, hydrogen. So what is this compound called? Butane. Okay. What is the name of this reaction? Clemmensen reduction. What is that reaction called? Clemmensen reduction. So what happens in Clemmensen reduction? Carbonyl groups like aldehydes, ketones with zinc amalgam in acidic medium converts to alkanes. Once again, repeat like this statement. Aldehydes, ketones with zinc amalgam in acidic medium converts into alkanes. Okay. Now, the same story can be repeated in basic medium also. In which medium?
Basic medium.
So, basic medium I told, I am mentioning basic medium, KOH. This should happen in heating condition. There is not required here, but here it is required. What? Heating. Here zinc amalgam you use it now, but here you need to use hydrazine. What to use? Hydrazine. Product formed will be same here again. Same. Remove that carbonyl oxygen, place 2 hydrogens. Okay. So now in acidic medium, what is the name of this reaction? Zinc amalgam. Fine. What is the name of that reaction? Clemmensen reduction. If I do the same reaction using hydrazine, basic medium under heating condition, this is called Wolff-Kishner reduction. What is that?
Wolff-Kishner reduction.
So, depending upon the requirement, you can prefer acidic or basic medium. If it is happening in basic medium, what is that name reaction? Wolff-Kishner. Acidic medium? These 2 reactions are over now. These 2 reactions. Okay, next one. In periodic table, if you remember, that diagonal relationship concept we have studied. Now, beryllium is diagonal with which element? Aluminium. So, beryllium and aluminium are diagonal in relation. It means their chemical properties are similar. So, now if I hydrolyze these carbides, either it can be aluminium carbide or it can be beryllium carbide. If I hydrolyze them, I am going to get same product. What is that product here? Methane. What is that product here? Methane. So whether it can be aluminium carbide or beryllium carbide. If I hydrolyze it, what is the product formed? Methane. Okay. So if I do hydrolysis of magnesium carbide, I will get acetylene. What is that?
Acetylene.
Like ethane, you know now, C2H2. That will be the product. When it is magnesium carbide. If it is aluminium carbide or beryllium carbide, I will get methane. Okay, remember. Next one. Again, these 2 reactions are important. Take carboxylic acids, CH3, CO, OH. What is this? Carboxylic acid. Very simple to understand, just follow me. You just read this with soda lime. Soda lime means what? NaOH plus CaO. Calcium oxide plus sodium hydroxide. This combination is called what? Soda lime. So, carboxylic acids with soda lime gives you alkene. What they will give you? Alkene. So, what is this alkene means? See, this is CH3 is there now. This alkyl group is there now. Whatever alkyl group is there, to that alkyl group you put 1 hydrogen. Methyl is there. If I put 1 hydrogen, if it is ethyl, propyl, that is your answer. So methyl is there, so your answer should be like CH3, 1 hydrogen. Methane is a product. So you just generalize it like this. R group is there. So what is my product? R with 1 hydrogen. That's it. Here carboxylic acid giving alkane. See, carboxylic acid contains how many carbons here? This alkyl group along with 1 more carbon. But this carbon is not there here. It means if my starting material contains n carbon atoms, my final product is containing n minus 1 carbon atoms. For example, this compound is something like CH3, CH2, CO, OH. How many carbons are there in the starting material? 3, that is propanoic acid. What is my final product formed? Ethane, because this carbon is removed out. So one carbon is less. Here 3 carbons, 3 minus 1 means 2. So what is my product name now? Ethane only. Is that clear, everyone? So now what you are removing? You are removing this CO2. Which, what you are removing? You are removing this CO2. Okay. So name of this reaction is decarboxylation. What is that? Decarboxylation. You are removing CO2 now. That's why you should call it as that carboxylic, like this CO2 group and this Na, sodium. It will form Na2CO3. Okay. So soda lime with carboxylic acid. What is the product formed? Alkane. Is this clear or not, everyone? Okay. Next one. Kolb's electrolysis. See, in the last classes, electrolysis process we discussed in the electrochemistry. Okay. Now let us quickly revise using this coal-based electrolysis. Like this is a carboxylic acid now. Carboxylic acid na. Carboxylic acid ki manam edana base add cheste em avutadi, it will form salt. Acid plus base forms salt. So I am taking that carboxylate salt now. Sodium carboxylate I am taking. I am electrolyzing it. What I am doing? I am doing electrolysis process to this. So in electrolysis we have two things. One is cathode, and this solution contain water also. That water also get ionizes. What are the ions will get from water? H plus goes to which side? Cathode side. Here H plus. OH minus comes to this side. OH minus here from water. This H plus ion from water. Okay, this is fine. Again, if you remember that electrochemical series, okay, anions if you compare, so this anion will get deposited first. It means this is more right side. Okay, now what happens? It will undergo oxidation. Oxidation means what happens? Loss of electrons I can say, or addition of oxygen I can say, like that. But here particularly loss of electrons. See, this electron is getting breaking like this. So RCO, O radical is formed. See, idantha gurtu pettukovalante avasaram ledhu, just electrolysis process telusu kada ani revise chestunanu nenu. Okay, so we get, see, I have removed one electron. Loss of electron means what is it? So after removing electron, see, radical is formed. Radicals are highly unstable now. So this radical, and from this bond one radical comes and comes out as a CO2 gas. ఈ bond లో నుంచి ఎన్ని electrons మనం వాడుకున్నాం? It means one more electron will stays with this R group now, like this. Yes or no? ఇంతేనా జరిగేది? Okay. So now if I use these two carboxylate ions, I am going to get these two radicals. From these two alkyl radicals I am going to get. How many alkyl groups are there? 2. So this electron pairs up and gives you RR kind of product. Trick cheppesta final ga, but this is the mechanism you need to know. So what is the gas releasing here? CO2. At which electrode it is releasing? Anode. They will ask. What happening at anode? Oxidation taking place. Electrons are released. CO2 gas is released. Product is also formed at anode. Now the electrons are releasing now. If I do 2 moles, I am getting here 2 moles of electrons. That 2 electrons comes this side towards cathode side. So Na plus H plus, which ion will get converts? H plus or Na plus? H plus. That H plus 2 H plus and 2 electrons converts into H2. That's it. Na plus remains as it is. So this Na plus and this OH minus. NaOH. During this electrolysis, what is this formed? NaOH also along with our products. Okay. So now at cathode, what is released? NaOH, you just keep it aside. H2 gas. So this is a JEE mains question, advanced question, even NEET question. They will ask you, what are the gases? Like H2 gas is released at cathode, CO2 gas released at cathode, CO2 gas released at anode, H2 gas released at anode. Like this, 4 statements will be given. What are those correct one? H2 gas at cathode, CO2 at anode. Product formed is also at anode. Now you just see, if there is RCOO type of compound, we will get like final product as RR. Just the R groups ni join చేయండి, couple చేయండి, that will be your final product. Okay, so it means if this is the compound I have given and I am asking you to do coal base electrolysis, what is your product? చెప్పండ్రా బాబు. RR means this R group, R group. Okay, now do this both process and tell me what is your final answer. Soda lime, Kolb's reaction. First, soda lime came చెప్పా, just CO2 remove చేయండి, whatever the alkyl group is there that converts into respect to alkane. Like how many carbons are there here? That is ethane, CH3, CH3. What about this one? Coal base. What is this product? This is alkyl group now. Ethyl, ethyl. But. That's it. Got everyone got this? Okay. Next one. ఇది కూడా గుర్తుపెట్టుకోండి. You can have anything like alcohol, it can be aldehyde, it can be ketones, it can be carboxylic acid. If I treat that with HI, red phosphorus, or simply phosphorus also they may mention. What I am saying, alcohols, it can be alcohols, aldehydes, ketones, carboxylic acids. If you treat this with HI and red phosphorus, you get respective alkane as a product. For example, ethanol with red phosphorus, HI and red phosphorus, ethane, butanol, like that, respective alkane is formed. Okay, starting material లో ఎన్ని కార్బన్స్ ఉన్నాయో ప్రోడక్ట్లో కూడా అన్నే కార్బన్స్ ఉండాలి ఈ ప్రాసెస్ చేసేటప్పుడు. ఓకే, ఇథెనోయిక్ యాసిడ్, ethane, propanoic acid, like that. Okay, fine. So you just summarize this table in your book after the class. Okay, okay, just answer me this fast. I know you can easily answer fast. Okay, let's summarize this with one or two things. అర్థమైంది అందరికి ఇది? ఓకే, నెక్స్ట్ ఫిజికల్ ప్రాపర్టీస్ ఆఫ్ ఆల్కేన్స్. వెరీ సింపుల్, ఒక క్వశ్చన్తో కంప్లీట్ చేసేద్దాం. సో వాట్ దే ఆర్ ఆస్కింగ్, బాయిలింగ్ పాయింట్స్. Okay, the correct order of boiling point of following molecules. See, boiling point, see what I am writing. Like this I am taking 4 different compounds. You just imagine you have hexane liquid. Now what you have? Hexane. It means this is one hexane, this is another hexane. Like that, more number of hexane molecules are there here. Okay, So between them, what we have now, there is some interactions, like molecular interaction between this molecule and second molecule, third molecule, like that. If more interactions are there, they are more close to each other. If they are more close, they will be in the liquid state. Right now. So if I want to convert them into gaseous phase, I need to supply more amount of energy. It means more amount of temperature is required. Right, up to here it is clear. Now consider, there is a branch. See, with the same molecular formula, I am writing a pentane chain with one branch. It means also, this is also contains 6 carbons. This also contains how many carbons? So now due to this branch, between this molecule, above molecule, this molecule and this molecule, one bond, like one group is there interacting. So now what happens? Intermolecular force, what happens? Is this same as like this or less here or more here? Less. Why less? Because this branch is disturbing that intermolecular forces. So as number of branches increases, boiling point decreases. So for isomers, which is having highest boiling point? The N isomer, less number of branches, more is the boiling point. See, all of these 3 are isomers. Yes or no? Isomers or not? These 3 are isomers or not? Yes, tell me which is having more boiling point? C. Like this. So I can say boiling point branches. This is a story when isomers case only. Normally for different compounds, boiling point increases with molecular weight. Greater molecular weight, greater is the boiling point. Like butane, hexane, octane, like that. So now answer me this. Same. N-hexane means a straight chain. 2-methyl means one branch. 2 branches. Ante. Okay, next. Now you have studied about preparation of alkenes. Okay, now chemical properties. Okay, next. Okay, look at this first. Alkanes are also called as paraffins, we studied. Paraffins means they are less reactive, right now? So it means at normal condition they won't show chemical reactions. But upon heating, or using sunlight or specific frequency, it shows reactions. Okay? So now, these alkenes I am treating with halogens. With what I am treating? Halogens. So during this reaction I will use sunlight or frequency. They will mention like that. It means what happens, this sunlight will break this like XX molecules into X radicals. It means what type of cleavage is taking place? Homolytic cleavage. Homolytic cleavage gives you free radicals. Okay. So now they will mention like methane plus a Cl2 in presence of sunlight or heating condition. Okay, they will mention like this. Now here there are 2 ways to indicate. If I say chlorine is excess, what is excess? Ante chlorine ekku undi ani ardham. Appudu em avutadi, each chlorine react with this carbon. How many hydrogens are there, ma? 4. All 4 will be replaced with each of this chlorine. Final product is what now? CCl4, and 4 hydrogens are there now, so 4 HCl will be formed. Okay, so this product will be major. Please wait. This product will be major when I am saying CCl2 is taken excess quantity. Which is excess? But if the same story I am taking methane with this as excess and Cl2 as limited. Now what happens? Sunlight. First this bond breaks and gives you radicals. Each chlorine radical, like radicals are highly reactive, highly unstable, more reactive. So each radical will take one of this hydrogen. ఇప్పుడు ఇక్కడ hydrogen తీసుకోవాలంటే చూడండి, how many bonds are there? 4 bonds. For this chlorine bond formation, 1 electron is there. How many electrons taken from this hydrogen now? Out of this bond, 1 more electron. అంటే ఇప్పుడు ఇది బాండ్ ఫామ్ అయితే ఇక్కడ రాడికల్ ఫామ్ అయినట్టే కదా. సో యూ ఆర్ గోయింగ్ టు గెట్ మిథైల్ రాడికల్ ప్లస్ HCl. Now methyl radical is highly reactive now. That methyl radical and 1 more chlorine, like that reaction takes place and finally gives you like this kind of product. Actually it follows like 3 steps are there. First initiation, propagation, termination, like this 3 steps are there. I'm not giving all those mechanism steps, but you just remember, if I say methane as excess, what is my product, major product? Methyl chloride. If chlorine is excess, CCl4. అంటే సార్ అక్కడ నుంచి ఇక్కడ డిఫరెన్స్ ఏంటి సార్ అని అంటే, సి ఫస్ట్ స్టెప్లో ఒక హైడ్రోజన్ రిప్లేస్ చేసాం, మళ్ళీ రియాక్షన్ రిపీట్ చేస్తే ఇంకొక హైడ్రోజన్, మళ్ళీ రిపీట్ చేస్తే అట్లా CH3Cl becomes CH2Cl 2 again CCl3H, ఫైనల్గా ఏమొస్తుంది అట్లా. when that will be formed, if I take this as excess, this is excess, methyl chloride is a major. So now what you are seeing, one hydrogen radical replaced by one chlorine radical na? So you should call it as free radical substitution reaction. What is that? Free radical substitution reaction. ఇప్పుడు మనకి different halogens are there, so which halogen is more reactive they will ask. So fluorine is more reactive, then chlorine, bromine, iodine. See, generally this is the reactivity order. Fluorine reaction we can't even control in the labs, so that's why we won't prefer this reaction in the labs. That is highly exothermic, like vigorous, it will be very fast, so won't prefer this. And iodination is very slow. For iodination process we require some oxidizing agents like HiO3, that kind of oxidizing agents we will use when we are doing iodination. So it means it is convenient for which process? Chlorination and bromination. See ma, I am writing CH3, CH2, CH3. They will ask you a question like this. What is the product formed during the reaction? What is the product formed in monochlorination? Monochlorination means what? Okay, hydrogen ni తీసి chlorine insert చేయాలి. So where I can do that? See, this methyl groups are same now. So you are going to get CH3, CH2, CH2, Cl. Even if I do the same process here, we'll get the same product. Okay, this is of A type of product. Next chlorination, I mean, what is the next possible product? Igo, madhyalo okati unnadiga. So that will give you, if I replace that hydrogen, we'll get CH3, CH, CH3, Cl. This is B type of product. So A type, B type products. So now how I am saying how many possible products? Just identify type of hydrogens we have. This terminal are same. Let us say them as A type. Middle one different now, B type. So A type product, B type product. They will give the compound and they will ask how many possible or how many types of products are formed on monochlorination of a given substrate. What to do? Identify like types of hydrogens we have. See, ఇక్కడ ఫ్రీ సబ్స్టిట్యూషన్ జరగాలంటే ఏంటి, ఒక హైడ్రోజన్ వెళ్ళి దానికి ప్లేస్లోకి క్లోరిన్ రావాలి. సో దేర్ మస్ట్ బి అట్లీస్ట్ 1 hydrogen atom, then their reaction takes place. Okay, that's it. Extra ఇంకేం వద్దులేండి. Okay, next one. See, this is a straight chain now. Straight chain, upon heating with anhydrous AlCl3, it will get branches. 4 carbons with 1 branch. Okay, so this process is called what? See, first one and last one isomers only now, so you can say them as isomerization. For isomerization, what is the reagent you are using? Anhydrous AlCl3 under acidic medium heating condition. One more, aromatization. Remember this. Aromatization means aromatic ring, like benzene ring contains how many carbons ma? 6 carbon. See, if I have my starting material 6 carbons, listen this clearly. If I have my starting material 6 carbons, the product formed is hexane. If I have my starting material 7 carbons, heptane antam. That heptane gives you, see, if it contains 6 carbons, hexane, that gives you product formed will be benzene. 6 carbons ni anko starting material lo, like hexane la, like this hexane only na, hexane upon aromatization will get benzene like C6H6. If this starting material contains 7 carbons, here also first it will form benzene ring. How many carbons extra? That you put here as a methyl group. Clear everyone? If 2 carbons are extra, it means octane case. Put 6-member ring first. How many extra? 2. The 2 put like this as ethyl group, you will get ethyl benzene. Otherwise, adjacent side like this. Don't put any other places, only these 2 places. Dimethyl benzene. Okay? Now, during this process, what is the catalyst used here? Like Cr2O3 plus Al2O3 condition. High temperature like 600 degrees Celsius and high pressures are required. What is this? Cr2O3 and Al2O3. ఇప్పుడు క్వశ్చన్ చూపిస్తా. Look at this. What they have mentioned? What they have mentioned? What are X and Y respectively in the following reaction? How many carbons are there? 7. 7 means benzene with one methyl group. So this is the product. So now what is the catalyst? I mean this one catalyst I should, reagent I should use? Look at the options. D. Perfect. Next one. This is benzene ring is stable ring we are saying. దాని గురించి మళ్ళీ మనం డిస్కస్ చేద్దాం నెక్స్ట్ క్లాస్లో. సో దిస్ వన్ ఈస్ హ్యావింగ్ మిథైల్ గ్రూప్. వాట్ ఈస్ ద రియాక్షన్ దేర్ ఇస్ బ్రోమిన్ heating. So this won't involve in the reaction now. Bromine will break into 2 equal halves and reacts here only. ఇప్పటిదాకా ఫ్రీ రాడికల్ సబ్స్టిట్యూషన్ అని చదువుకున్నాం కదా. సో one of this hydrogen is replaced with this bromine. So you are going to get a CH2Br. Okay, this is your final product. Okay, right. So the remaining thing will continue next. And in the evening class, if possible, we'll do questions. Try to be here. Okay, fine.